Good afternoon and welcome everyone to today's session with Josh Ogden from AVSS. We are going to be looking at their parachute recovery systems and flight termination systems as a means of compliance to fly over uninvolved people and in BVLOS operations. As we know, work's going on in Europe and the UK and obviously the US to determine technical standards for systems such as parachutes and flight termination systems that will be accepted as means of compliance with safety requirements. And I think Josh is going to have an update on this in particular for us. Josh himself is the joint founder and CEO of AVSS, so we're delighted that you're able to join us, particularly given the time difference as well. So I appreciate it's rather earlier in the morning for you than it is for us.
Yes, thank you for having me today.
It's our pleasure. I'm much looking forward to finding out more about this myself. So I am going to hand over to you and let you carry on. I'm going to mute my own microphone and video as well.
Perfect. Thank you very much, everyone, for joining today. Again, as Josh Ogden, CEO of AVSS. AVSS is a Canadian company that sells products around the world, and we focus primarily on parachute recovery systems and flight termination systems. We do have another side of our business related to guided delivery systems, which I'll touch on lightly. So for today's presentation, we're going to briefly go over about AVSS, things we do, and ultimately focusing on the parachute recovery systems and flight termination systems. We'll dive into some of the key features of those products and what are required from like an industry standard, a global standard perspective, and then some practical requirements for PRS and FTS. A little biased, but from our perspective of what it actually takes to build these systems. I think this is something in the market that isn't well known, and there's sometimes assumptions on oh, I'll just slap a tube on a drone and I'll be good to go. And so I'll explain some of the testing and the requirements that are key. So about AVSS. AVSS is a Canadian company. We are a DJI ecosystem partner. We work with different drone manufacturers such as Skydio, AV, and more. And we have the largest DJI distribution partners around the world for parachute recovery system companies with over 50 dealers that resell our products. Additionally, we do sell guided delivery systems, which are critical resupply, more military and emergency management applications. This is kind of some of our network, as you can see, in primarily North America and Europe. We have a few dealers in the UK, some in Australia, New Zealand, and those are growing steadily. Basically, when you look at a parachute recovery system and a flight termination system, nobody buys it until they absolutely need it. You know, it's an extra cost, there's new weight, there's changes in operations. So it's really about when you build the product and sell the product, it's about going into markets where having these extra safety systems, the regulator has determined you can do more missions. AVSS has built out an ecosystem over the last 7 years, including drone manufacturers, resellers, end users, integrators, and support partners. As I've mentioned, we work with some of the top drone manufacturers, some of the largest resellers in the world, as well. Our end users are typically either engineering services, drone services, telecom, public safety. Those are the kind of the key outside of the drone delivery companies. And then we're integrated. The thing with a parachute recovery system is just not an isolated product. You have to work with other ecosystem partners, and that's more than just the drone manufacturer. You know, everyone's using different softwares for different applications, and this is where we focus on, as well as making sure our product is integrated with different solutions so that you have that full end-to-end solutions. About AVSS, we are a dominant piece in the market. As far as in Canada, we're one of the top commercial drones. This list here doesn't include DJI, and I believe SenseFly is missing from this. But basically, we're a top registered product, and in Canada, we can demonstrate that because of the way in which our registration system, when you register a parachute, you're registering it as a Ops Over People product, and so you can kind of see the data from that from FOIA requests. And then as far as AVSS and market share, as of March 31st, 2023, you know, on the M300 alone, we're 84%. So we're quite a dominant piece in the Canadian market, and we're seeing that growth as well in the European market and other markets. And it comes down to the quality, understanding regulations. Again, I can't harp enough. people buy parachutes and flight termination systems for compliance. And if you're buying a system that isn't going to give you the compliance, it's nice idea to save the drone with a parachute, but it's never guaranteed. And it's something that we don't push. We think that, you could land on some gravel, on some concrete, and the drone's made out of plastic. It's just a reality. Some companies we work with include Skydio, we're their parachute vendor. We work with AV out of the Netherlands, Workhorse, a drone delivery company out of the US. And as well, we've got some really cool use cases. We've been working with clients around the world for several years now. And in Canada, we've been able to fly over people since 2019. Our products came to market for the first M200 in 2020, the M300 in 2021. So I'm going to show you some use cases now that we've seen customers do around the world. Starting off with a use case here in Canada where the National Research Council of Canada and Transport Canada were actually working on flying drones over people in downtown cores and to assess the wind effects in those corridors. And so here's an example of a video, if it wants to buffer, that we flew last year, and by flying our customers. So this is where they're flying, and again, this in certain markets, this is illegal. US, you're not quite there yet, but in Canada, it's possible. The UK, I know there's trending, and I know there's a lot of change between the European rules, the Old English rules, and how things are going. But these are the examples of what's coming, and I think is the highlight of these kind of use cases. Other use cases are, this is the Grey Cup, the Canadian Super Bowl, 30,000 people in attendance, and customers being able to fly over them for public safety. We've also had work done in Europe where, they were flying cross-border Accenture from Germany through Belgium to Netherlands. And then in Hungary, we've had customers receive the Luke certificate. And then in New Zealand, we're seeing customers get approvals as well. And all this common theme outside of the US is related to the JARA SORA, M2 mitigation, medium robustness, high robustness, looking at MOC 2511, MOC 2512, all those great acronyms about flight terminations parachutes. And luckily with the JARA SORA being adopted, and it seems like the UK is really pushing towards that there is some availability of product on the market, because the European market, the Canadian market, the Australian market, New Zealand market has these requirements, and similar to the US, but a little bit different. The US market is same, but different. And as well as some customers we work with, drone as first responder. Chula Vista is a key police department in the world who runs drones. I believe they're up to 20% of their 911 calls are being sent by drones. They have locations across the city. And these are, again, some examples of customers who are really using our product and why they're using it. Additionally, we do work on some emergency services, military applications with critical resupply. We basically have guided delivery systems where we can control where a parachute lands. This is an example of some of the work in our First Nations community in northern Canada, where they live on it. There's a group of community on an island, the other on the mainland, and that ice, when it breaks down in the springtime, you can't traverse it with a snowmobile. There's boats can't go across. So they're looking in and they're assessing the technology right now. I can show you a video of testing. This is last August. We were out there training them, doing testing, and you can see kind of just like the application of the technology. I sometimes reference it as kind of like a Call of Duty airdrop for those who are video gamers. But basically it's a guided system pulling these parachute lines and guiding it to a target, a predefined target. And again, there's kind of dual applications there. And we've got different iterations as far as this technology goes. And as you can see here, it'll kind of zoom right on in and, lands within 20 meters of a target, up to like 2 meters of the target. And then the same technology being applied, but instead of off a drone, we can actually throw it over an aircraft. Again, this technology is relevant to the drone industry, but it's really about the resupply requirements, whether it's in those two kind of fields of applications. And this is just kind of some of the technology. And for Canada, we have such a large swaths of lands that we don't always have infrastructure on the ground to get to places, or during the winter time. And here's an example of the landing accuracy. The blue tarp was the target. So jumping into why PRS is required. So a lot of people, again, depending on what market you come from, there's funny stories I hear in Chile that you need a parachute, but it doesn't need to be powered on, so they buy the cheapest solution. I know that in France, the rules, our company started because France had rules and we assumed other countries would follow on a very basic level. And when you look at the French rules, the requirements from the previous were, 10 hover tests. And what we're starting to see though is more of an acknowledgement. I was speaking with a company in South America yesterday, and they were talking about the need for ASTM, F3322 parachutes now, not just the basic testing. And this is where parachute systems are becoming more from hobby and more that commercial industrial, and it requires a lot more testing, and there's more costs, and you're starting to see more companies basically bow out of the race of not wanting to build all the products because there is a cost for overhead, but there are some key features that are required. And why a parachute? This is an article by J.K. Stoltz. He was an independent contractor at the time he wrote this article, doing his own regulatory services in the U.S. Now works at Skydio on the regulatory team, but calling out how the new rules in the U.S. were coming in, and this was very much a trend. And we're early adopters of this. We believe this in 2017, and you're starting to really see it grow in 2020, 2021, and today it's just like accepted, and that's why I'm here today. Some countries that require parachutes and why they're required in Canada. When we have advanced operations, so we're flying over people, or when we're doing like BVLOS missions, the EU sometimes require it. For SORA, or we look at the EU specifically, the M2 mitigation, predefined risk assessments and enhanced containment. And then the US, we're looking at parachutes for certificate of authorizations and operations over people. So in Canada, we have a really simple system. Our system includes just go on a list, check to see if the drone's on there and if it can fly over people. As you can see in this example, the M300, M200 from DJI is not declared over people. So then with our system, we make that declaration. Now, this system's been an interesting, and we can touch on later, but in Canada, we've had a self-declaration system to really, the regulator saw the need to just let the market kind of evolve, and they didn't have time to check every single declaration. So they created kind of an honor system. But in February, they actually revoked hundreds of drones from that list because of false declarations or not submitting paperwork. Some of it was administrative, the right email wasn't connected, but ultimately our self-declaration process allowed the industry to grow. And what we're seeing now from an industry perspective is there are some bad players who are abusing it, who are making false declarations. There's some who are just making mistakes. They didn't know that they did something wrong. But ultimately, it's an interesting thing where we opened up the floodgates for self-declaration, and now we're realizing, I think, that we need to check some paperwork. And there was an open letter signed by approximately 20 industry members saying to Transport Canada, like, hey, there's public safety people grounded, there's businesses that couldn't operate because you let these people make these declarations, and how do we tighten this up? So now going into more about the key features of a parachute recovery system. Ultimately, when you're looking at these systems, there's some key ingredients, and there's some nuance in each ingredient, whether it's what's the level of hoppiness in the beer, we could say, but I'm going to stay on the high level of that. You need hops. So for example, for a parachute recovery system, you need an automatic triggering system. The photo here is a great example. This was a flight that was happening several years ago in Japan. I believe the flight had some other non-compliant issues, but on a general concept, this drone was dispensing candy to kids, and it fell and it crashed into people. If it had a parachute recovery system with an automatic triggering system, that parachute system would have detected that tilt at very much degree. Now, to go into some of the nuances, there are some parachute systems out there that are using just open source, kind of like an Arju pilot model, where if it exceeds, X degree, or if it free falls for X amount of seconds, it deploys. And those are basically the two only or three parameters. We don't have that system. We have a more complex system where we have algorithms that are looking for symptoms, looking for failures, looking for a single motor, double motor, full motor failure, looking and making sure we're adapting. And that's something that anyone who's coming out with an automatic triggering system, especially for the OEMs, when they say that, yeah, I can have it right away and you can tune it yourself, it's like, that means you're not considering all the variables. I can tell you from experience that an M300 falls differently from the sky than a Nightingale drone, than a Mavic drone. And those algorithms you can't just have like a simple model. There's too many, there's a high likelihood of false positives, your performance specs drop. So with an automatic triggering system, you need it, but you also need to question, how did you build it and what are the unique elements of it? Or is it just like, a simple hit this degree and deploy? Next is flight termination system. Sorry for the photo. It's kind of making the point on why we need it. A flight termination system's purpose is to prevent a drone from lacerating somebody. It's not to stop the parachute from entanglement. That's a nice to have. But the key thing about a flight termination system is we don't want to cause, like in Canada, a severe injury from our prop spinning. One of the companies that was removed from the Transport Canada list actually would be selling a parachute without a flight termination system. And then I've heard arguments, I think in Europe for one parachute company that you can do the Mavic CSC maneuver, for those who know, where you take the sticks and put them down into the corners. And that's still another issue. Well, your flight termination system from an ASTM perspective, and from our experiences, it needs to deploy at the time of failure or right before the parachute deploys so that you stop the motors. The entanglement risk is reduced, which is a nice to have, but ultimately you're stopping the propellers, all independent. I've seen this other company try to advertise a parachute and declare M2 mitigation where you have to do like the CSC maneuver, and it's like, wait, I've got to watch a drone fail, my parachute deploy, and then I have to react. And it's like, that's just too much risk, too much human response. And the human factor side of it is just too clunky in our opinion. And then this actually UK example on one of the key features is having a way to independently terminate the flight. This is especially important for enhanced containment in Europe, and I think the UK is looking at this as well, where if the drone fails like the PSDK on the M300, you should have another method at least to prevent that flyaway, or links over links. There's other ways, cellular, SATCOM, other methods. But the purpose of the manual remote is ultimately to give the pilot control and saying, you know what, my aircraft is leaving my operational zone. I don't feel comfortable. I'm terminating the flight. And this is an example, not without this one didn't have a parachute. It just kind of drifted away, but it highlights the example of where the drone can do and the air, any issues that come up. And then finally, ASTM F3322. This is an example in Switzerland where they were doing drone delivery and a parachute deployed and broke off. And one thing FOCA told the company to do is to go do the ASTM standard. And then again, this is where industry standards do matter. I'm quite critical of the recent European M2 mitigation requirements. One is ASTM, which is great, example one, but the second one is 2 ground activations, 2 flight activations, so 2 times in the air, 30 times on the ground. And it's like, that's not enough. I would never sell a parachute with 2 tests only. And I think these are the type of things that when we look at industry standards, it's really important to like, hey, people are coming here with real life experience. We've deployed thousands of parachutes. We know that there's a certain number of tests, there's a certain amount of flight data that you need to collect. And this is one of those things where it is an expensive test. Drone manufacturers, not all of them can afford to do it, or they choose it's not a priority and they go with the lesser. But I know from us that like this is our core business. This type of testing really sets the mark on like, okay, I'm a serious company and I'm looking and I'm servicing different markets. And then finally, some practical requirements, things that we do internally at AVSS to make sure we feel comfortable in the product that we sell. So some things that with these practical requirements, people are working with us. It comes down to product quality, regulatory compliance, and then the ongoing customer support. And this leads to our understanding of regulations and the products. So one thing with AVSS is we're very much involved with industry standards. When we started the company, these standards were actually already being drafted and published. We weren't invited to the table at the start because, in 2017, we were just starting. And over the years, we eventually joined these committees. But I struggle when we meet companies that complain about the standards where we were just given them and said, comply, and we figured it out on our own. We have some investment, but we have not raised significant amount of money. And this is something that it's a way in which we said, if you want to build a good product, you got to find the standards, you got to comply, and you have to be disciplined. And this is something that's separating us from the regulatory side of things. And this is where I think any parachute company or flight termination system company, it's really important that you're asking these questions on like, how are you complying? Can I see the paperwork? It drives me nuts when someone does ASTM F3322 and they don't want to give the data to the customers. They say, buy my system, then I'll give it. And from my perspective, it's a transcript like from university. These are your grades, these are your scores, this is what the results is. It's either you pass or you fail. And to not share that information, I've heard people complain that these reports are proprietary. It's like, no, it's not. Like, you're just saying what your descent rate is, what your failures were, and things like that. And so we, as part of the new standard that we're working on, part of it is to have some public dissemination so that end users aren't running around trying to get the paperwork, and the regulators can get it faster, and just trying to make this process smoother. As well, some practical requirements, and this is more for high robustness as well as thinking of the US market, is not only do you have a parachute descent rate, but you also have to consider the transfer of energy. In Europe's M2 mitigation, you'll see that there's the kinetic energy threshold of 175 joules or the transfer of energy of 80 joules. A transfer of energy, the way to think of it is a metal object hitting you with 3 kg of mass versus a drone with 3 kg has different injuries. It's just what the mass is made of. It's similar to 3 kg of feathers would feel fine, unless maybe they're wet in a bag. But this is some of the work that we do at AVSS is we go and we're doing this testing. Why? For regulatory compliance, ultimately. And we have to compare in the US this rigid object on the left-hand side to the mass of the drone. So this is an M300. This is destructive testing. And we've done it so far on the M300, the Mavic 3E, the M30, the M200, and some others. And this is the type of data that we're submitting for regulatory packages. And these are the key things that are looking at for the regulators. And I think as the industry continues to evolve and we get to BVLOS, these are the requirements that not only the functionality and features, but the testing that you'll see for all the drones. And ultimately, it's in the guise of safety. We don't want somebody on the ground feeling the pain of a drone falling from the sky. This is just the aviation mindset, the regulators. And then finally, some practical requirements with this is specific to the FAA is a means of compliance. In the US, to fly over people under what they call category 2 and 3, there's certain thresholds, but to even meet those thresholds and make declarations, you have to have a means of compliance. So we were the first one approved. We beat a university test site by, I think, 8 days in submission, and we were one unit ahead of them with the document number. But basically, this is a means of compliance that was approved on Friday. So the US market is now going to be opening up. And this is just the general theme to think of the practical requirements when you're investing in a parachute recovery system company and you're putting those products on your drones. You got to ask questions. Like, price is great. You can go find something cheap. And by cheap, I'm saying, for the M300, you can buy a parachute from, I think, like 1,400 American up to 5,000 American. We sell ours at 4,000 American. So there's those price range, but ultimately it's great that you have it. But what happens when it's not compliant, or it becomes a paperweight? And so this is where understanding where they are at regulatory, because these are things that for the end user's life, for the pilot's life to be easier, drone manufacturers, drone parachute companies have to do the work for you. We have to go out and do the testing, get the compliance, and make it easy. Now we get rewarded by easier sales, so you don't have to fill out paperwork and wait months on end for approval, whether it's a waiver, an SFOC, an exemption. Basically, this is the work that the companies are doing in the background. And this is just to highlight, when you're thinking of these investments, like, you should be digging in and like, is this product going to last as long as the drone? Like, am I going to have it for 3-5 years, or are my regulations, am I buying the cheapest thing just to comply today, but I'm not forward thinking? Now, as a business owner, I know you can't always think of the future. Sometimes you have problems today, cash realities today. But when you're looking at parachute systems, from our experience, it's like, there's companies that are on the right track. No, we're not the only one, but there's very few of us. There's less than 5 that are actually doing, and I would argue there's less than 3 of us that fully understand all of the elements that are required for the future of those BVLOS to make the pilots easier. And then some other items that are more practical with AVSS that we perform is we really try to understand the user. We deal with a lot of public safety. We deal with a lot of drone delivery companies, and their needs are just very different. We were part of the DJI Dock 2 launch, and it's April. It's 20 degrees today, but last Thursday we had snow for some reason. This is the Canadian winter, or spring, I guess. But that gave us a great chance. You'll notice there's snow on that top of the dock. We want to know, is that snow coming in? And these are the practical items that when you're working and looking at a parachute recovery system company, what are those ongoing testing programs? What work are they doing for the user to understand the elements that they're operating in? Or are they just saying, hey, here's my tube, go ahead, I don't want to be involved? This is stuff, again, for us, we think these are investments that we have to make the end user's life easier. This is the new Dock 2, it just came out, dealers are just getting it. And we're still doing ongoing testing. Why? Because what are all those unique elements? How does it land? How does it drift? How does it handle winds? How does it handle snow? And these are the items in which you'll notice with the parachute companies, sometimes there's a delay for the drone to the parachute coming out because the drone availability is limited and we need to do these ongoing testing. So when someone has something right away and they're shipping that day, you sometimes, like, maybe they worked with the manufacturer, but like you always have to question, like, how much ongoing testing did that company learn? And then some other things about ongoing testing. For us, we have a big net. Why? Because it's more practical to do quick testing and it's more cost effective. As well, we're running ongoing testing programs. Our parachute recovery systems, for example, are originally set for 12 months for repacking, but we want to extend that. We want to make the pilot's life easier. So we're now at 18 months. Why? Because we receive units from customers for repack, and we sometimes just give them brand new units, and we will store their units on our site, and then we do ongoing testing. These systems were packed for 2 years, and they were operated for hundreds of flight hours, thousands of on time. And so what we did was we ran this ongoing testing to say, can we extend that repack cycle? So now with the data, we won't say 24 months, but we say 18 months, and then once we hit 3 years, we'll go and do another set of testing. And from there, hopefully extend that out to 2 years. But this is the type of stuff that you have to be diligent on. Our parachute repack cycle, you'll see some companies just announce 2 years of a brand new product. And like, our view is, how did you come to that conclusion? Were you running ongoing storage, or are you just kind of guessing? And this is where, with a safety product, the marketing, like, every drone is probably going to lie to you that their payload capacity, flight time. With safety products, like, you need to know what works and what doesn't work. And I think that's something that's very vital for a company. And then finally, from a very practical requirement, is your parachute will deploy one day. Your drone will fail. Whether it's user error, whether the drone crapped out, it is what it is. But it's going to happen. And when that happens, our job is to work. So a parachute system is a very interesting product that you have to think of, okay, my drone's going to fly these missions for 2 years. And that parachute needs to work once, but it's probably going to be 2 years from now. And so when it works, we need to know why it worked. And so what we do is, if we have a parachute deployment, we ask the customer to provide us with their logs of the parachute and the drone, and we can we can compare, and we can look at failure modes, and we write a report. This is an example of a redacted report of just the first page. Usually will show why the failure, what happened. In this situation, a motor failed. It was doing an automated mission. It was taking a turn, and the motor failed, and the parachute deployed. And so the customers then take this, and they know that, okay, it wasn't a false positive. It was just regular drone failure, normal thing that's going to happen, and they can go either get it serviced or if it's within warranty. But from our experience, like, DJI's great to work with. They've never questioned one of our reports. They've been very honest, and this is the other piece, that when you have that parachute drone combination, there needs to be a good relationship between the parties, because when the drone fails, the pilot shouldn't be sitting there in the middle saying, is it the drone? Is it the parachute? Because now I got to go talk to the regulator. Like, there is a collaboration there. And so, especially when we're starting to think over people BB loss. So this is where, from our standpoint, this is another practical item of, when you're looking at a parachute recovery system, it's great to talk about all the positive, what it's going to do for you. Don't be afraid to ask, what happens when it deploys? What's this process look like? Am I going to be sitting around for 3 months waiting for a report? Am I going to be able to switch the system? What is that experience like? And that's something that I think, too, is just a practical requirement for doing that. And that's it for today's presentation. Thank you very much, everyone, for coming in. Happy to have a conversation and chat more.
Thank you very much indeed, Josh. That was absolutely fascinating. I'm delighted in particular that we've been able to entice you on to talk today, because these systems have fascinated me for a long time. Now, we do have a number of questions, so I will make a start with those, and then some questions that occurred and we were talking about yesterday, ones we'll continue on to, because I think those will also be of further interest. So the first question is, can we purchase the parachute recovery system to retrofit existing units? If yes, are there any constraints to maintaining the means of compliance?
Yeah, so depending on the drone, like, we have customers who are flying our quote unquote M300 product on different types of platforms. So we have a standard product, electronic module parachute pod, and then usually a brackets customized, and there's some auto trigger tuning. And with that, it's not just simply you can slap it on and go. There's actually some work there. So if you're an end user and you have an old drone, you want to put on a parachute, like we wouldn't offer that service. That's more of like a hobby level perspective from our side. It's got to be integrated. Now, if you had a drone in which you're like, hey, I've got 100 of these drones and I want to, or 50, and I want to buy parachutes, we can work with companies like that. But if you've just got a drone and you want to just do your own kind of DIY bracket and go, like that wouldn't be something that we offer. Again, it's not going to get you the regulatory. So you're at a hobby level there. And this is where the industry is changing.
Okay, thank you. For EASA, with the M2, do you achieve low, medium, or high robustness? How many points of mitigation do you achieve?
Yeah, so right now through EASA, when we look at the M2 mitigation, we have the testing data to get medium robustness. As well, there's a high robustness requires third-party validation, which we have. We're going to be submitting our own MOC for the high robustness for that. But to date, they have allowed for ASTM to be medium robustness or high F3322, but there's some extra work for the high robustness, including third-party training. And I think that's the biggest element is what is that third-party training qualified as? From our conversations, that's the only piece that's kind of left, and we're submitting paperwork for that basically. So today you can get medium robustness, but again, from a future-proof perspective, we have the requirements to get high robustness, where when you look at some companies that'll get medium robustness today, 1-point reduction, they're doing it off the 2 flight test 30 ground activations, but they're not going to get high robustness with that. So it's kind of an interesting piece of the market.
Is there a minimum altitude to allow proper parachute deployment?
Yeah, this is an interesting one. So there is a minimum deployment altitude. How do you reach that conclusion? So as you saw with our video, we're deploying at 20 feet above a net, and it's opening and it's slowing down. And if we were up another 10 feet, it'd be perfectly fine. So on the M300, we can say it's 18 meters is a minimum deployment altitude. However, you have to understand how the industry standard looks at it. The ASTM F3322 looks at MDA from an outlier perspective. Kinetic energy descent rate is averages, but your MDA is determined by an outlier. It's a little bit of a flawed test because you can have one bad pendulum. So parachute deploys and it kind of swings. It doesn't reach something called steady state. When it reaches steady state, that kind of where the the drone fails, parachute deploys, it reaches kind of steady state, and there's like a graph that curves, a line that comes down pretty consistently. And this is a flaw in the standard, but MDA ranges, and it also depends on drone. But typically you're going to see 25-ish meters up to 60 meters, depending. I've seen higher, I've seen barely lower, but not much. So that's kind of the practical side of it.
How has this is more for your organization than anything else, how has your ISO 21384-3 certification come into play, and have you found it helpful in your operations?
Yeah, so we're an interesting beast where
I'm going to ask first of all, what is that ISO? What does that ISO relate to? Because as far as I'm concerned, that's just a bunch of numbers.
Okay, I'm going to pull up give me a second. I'm going to pull something up just to make sure I quote this right. So ISO, so this is an interesting certificate that we did with a company called Ultimax out of Newfoundland, Canada, but they work around the world. So this ISO certification is about our operations. This is probably related, could be related to this is actually an interesting point on, I wonder if ISO certification would lead to high robustness from a training perspective. Something I'd have to look into, but it's basically an internationally recognized standard. ISO, people know ISO 9001 and all the different ISOs around the world, but it's for operational procedures. And for us, why we did this, why we invested the time and money was basically we looked at saying we're a safety company. It's very ironic if we have an unsafe mission. So we're very diligent, and luckily for us, we fly at the same 2 test fields. We have a summer field and we have a winter field. And so these test fields allow us to kind of reuse the SORA, but we do a SORA for every flight. And this allows us to maintain the certification. And so internally, it makes us feel better, as well as on the outside, we've worked with different accreditation bodies, such as we work with, we're an importer, exporter of initiators from like similar to airbags. We use those in some of our products, a pyrotechnic solution. And when we talk with the regulator and we explain how our product's built, but also our procedures, there's extra merit for this ISO certification. And so for us, it gives us a peace of mind internally from an executive perspective that we're following very strict procedures. From a legal standpoint, our lawyers like that we've taken that step and shown due diligence, as well as from the governance perspective. And then from a practical side, seeing the benefits when we're looking at our operations.
Right. How much
but if you
does
want to
a
learn, if you want to
carry
learn
on.
more about, if you want to learn more about ISO, there's a Canadian company called Altomax, ALTOMAXX, that does this accreditation, and they're working primarily offshore as a service company as well. But they're, you're working offshore, that's just a level of accreditation, right? And I'm sure any pilot that's doing those operations know. And so yeah, check them out.
Oh, will do. Thank you. How much does a parachute recovery system cost for, say, a DJI M30 or M300?
Yeah, so we'll have something for the M300. Baseline will be, I believe it's 23 or 2,500, and then the enhanced containment with the independent FTS is another $200 on top of that. The M300 is 4,000. M300, M350, 4,000. When you look at those M300 products, you'll see ranges. I think that the cheapest solution out there is like $2,400 or something, $2,000 with not good paperwork. I've seen some without flight termination systems, which drives me nuts. It's like, it's possible to do. Why are you selling just a tube? And then from a high end, I think there's some that are over 5,000, but we're right in the middle, but with all the paperwork.
And can we purchase your system in the UK? I think you mentioned earlier actually that you had some resellers. Yeah,
we work with IRED, so Tim out of IRED, Volatus. Everyone knows Tim, I assume. Tim should be here today. If he's not, I'm disappointed.
He's not official.
All right, we gotta call him. Yeah, share the word. Fine, Tim. As well as we worked with Ethan in the past, and those are the two main ones. We're always looking for more dealers. Typically, we work with dealers that are already selling DJI products, enterprise dealers specifically. But yeah, and then we have those dealers there, and then there's purchasing direct.
Yeah. So we've covered the questions that are here immediately. I'm going to go back to, please, sorry, apart from anything else, please continue to add in your questions. But while you think of some of those, we've got some questions that we came up with yesterday that Josh said he hadn't actually already covered in the presentation. So we're going to add those in as well. First of all, is the parachute designed to save the drone itself?
No. If you buy a parachute to save your expensive asset, don't buy mine. I don't want your call, because ultimately the parachute's job is to reduce it to a kinetic energy. For the Mavic, you can have the drone come down at like 5 meters per second and achieve that goal. For the M300, you need to come down at like 3.5. But ultimately, I can't control where that's going to land. Is it concrete? Is it water? Ultimately, the job is you have regulatory approval because you're flying over people, or could be, and you're diligent. And this is a mitigation for the bystanders. And so when we do third-party testing, I believe it's 45% of the time there's no damage, visual damage, everything go and fly again. But 50% of the time there's going to be some damage, props, legs, things will break. And then once out of 45, you have a terrible landing that a gust of wind comes in, drags your parachute across the field. So there's just too many dynamic elements. I am aware that there's some parachute companies that will say there's minimal damage, but like they can have fun when someone's lawyer calls them for $100,000 lighter that broke.
So when we've been talking about the parachute recovery system and the flight termination system. What's the difference and how do they combine? Or is it just the one? So we've talked about the parachute recovery system and the flight termination system. Are they essentially sort of synonyms for each other, or can you use one without the other? How does this combine? I think this is a really key issue that people need to be able to understand when they're sort of looking at your system.
I would never buy a flight termination system. Sorry, I would never buy a parachute recovery system without a flight termination system. I may be in a situation where I want only a flight termination system because I'm acknowledging that my drone's going to blow up if I press the button, because when it hits the ground, it's going to explode. But the parachute recovery system needs to have a flight termination system. One, practically, it's nice to not entangle with the propellers that are spinning. And for bystanders, we do not want a drone coming down at 3 meters per second, nice and slow over a crowd with spinning blades that are going to lacerate. Now, flight termination system alone is an interesting one. The Irish, I really appreciate the Irish's advisories and their feedback that they provide to their pilots. They have good documentation where they talk about that a parachute isn't a must, an impact reduction system is what they reference it as. But there's a human factor side. Are you going to delay that decision because you know your 100 grand is about to fall because it's drifting towards an airport and you got to make a decision? Or they believe from a human factor side that you're more inclined to press that red button when you know at least there's a parachute. So I think there is some merit to that conversation, but ultimately your parachute recovery system must have flight termination system, in my opinion. And from a regulatory side, like yeah, there's some weird like M2 medium self-declaration where you can do it retro, like you can, again, that C-to-C maneuver. But again, human factor wise, you're never going to be fast enough. It's going to be a disaster. And you saved a few $100, that's going to cost you way more. But you could have a flight termination system without a parachute. It's just going to default be expensive.
Yeah.
Not the system, but the outcome.
Can you explain the difference between base kinetic energy and the transfer of kinetic energy and why that's important?
Yeah, so this is a topic that seems to have escaped a lot of people. And it's very intuitive once we discuss it as like, let's not use all the jargon. Let's just talk about it practically. So there's a formula that says kinetic energy equals mv squared. And that is not separating the type of mass, metal, wood, plastic, foam. And this is where the Europeans have said 175 joules of energy from a baseline, just do a calculation. And then the transfer of energy was the crash testing I was showing you, where a transfer of energy from plastic versus metal. And this is where, when you're looking at it, this is important because you also have to account for wind. Some people will only do descent rate based off zero wind, but like, I don't know how many zero wind days there are in England, but I don't think there's many. Yeah, so you have to account for wind. And this is where the Europeans are good, where I think they're saying you have to account for like 10 meters per second winders, I believe. Maybe it's a little lower, but ultimately wind needs to play in. So that comes in as well with the transfer of energy, because your mass, if you're using a baseline formula, you're not incorporating that other axis. And so this is where transfer of energy is really the true effect, and it's a lower threshold because it's the actual true transfer, where 175 is kind of a baseline. Okay. And each country is different. Like in the US, interestingly, I guess their human anatomy is different and their skulls might be thinner, that they have a threshold of 35 joules. And it's something that it really baffles me that we have different kinetic energies in different countries. We design for the most conservative, and that's why sometimes our system will be a little bit heavier than those that are only designing for a market that has really loose regulations. But yeah, it's an interesting piece when you're buying a product, is what markets it's complying with, because just because you comply in one country doesn't mean you won't the other, even though we're all human. And I feel like it should just be standardized. But the powers that be are wiser than me.
So funnily enough, that leads me nicely on to the next question, which was, can you discuss the FAA, EASA, Transport Canada, sort of inter-industry standards, and how that sort of affects your system, the system? I mean, you mentioned just there the sort of the difference in the kilojoule side of things, but how does the rest of it, is it affected?
We choose, like in our company, we just choose the most stringent requirements and say, if we meet this, we'll meet the rest. Let's just design to that. That's just an engineering decision. But those decisions require significant work on our regulatory team. We read a lot, lots of documentation, too much probably. And it's something though that you have to start mapping things and saying, okay, the US, you need to have ASTM F3322, you need to do ATD, which is 3389, you need to have a notification process, a safety defect process. and this really cumbersome system. In Canada, it's a self-declaration. One means of compliance, but not the only, is the ASTM F3322. In Europe, you have like I said, medium robustness. You can get away with using ASTM F3322 or your simple 2-flight test, 30 ground activations, which I don't agree with. But then for high robustness, you need industry standards. So basically, our strategy and how we make it work for everyone is we pick the highest point and go for that. Let's not play around that a customer is going to have a problem.
Yeah, great. We have another question, which is, how does a parachute recovery system, flight termination system, support enhanced containment?
Yeah, so in Europe, enhanced containment is classified as MOC 2511. What it basically says is you need to have an independent flight termination system, which means if a component of the drone fails that you're communicating to the autopilot, they're worried that it's not going to work. So you need to demonstrate that it's not connected. But basically, the way is you're interrupting at the power source. So instead of sending a shutdown command through a PSDK to tell the motors to stop, for example, on the M300, we're just stopping the power right at the battery source. And that's where you get the independence. It's heavier, it's a little more expensive, but the enhanced containment is basically they want it working at 0 meters and up, and that you're essentially in an environment where the air risk class is higher and you need to terminate the flight. You know, you're the great example, you're near an airport and your drone just buggers off towards the airport. They want you being able to terminate that. Now it can be through a manual means or a geocode means. There's different means to accomplish that, but that's where that independence piece and it looks like different countries, like we noticed that Ireland, Switzerland, they're very needing of this, and like you go look at where all the aerodromes are and you're like, oh, that's where all the population is, that's where the pilots are flying. You don't need this when you don't have that air risk class, but basically it's the enhanced containment is not about the kinetic energy per se, it's about containing the zone. And I think the enhanced containment in Europe has received some scrutiny and some critique, so much so that like the Swiss have come out with an alternative means of compliance because they don't think everything is enhanced. And I've heard somebody from the FAA argue that like from a mathematical perspective, the probability that your drone flies over to the airport, hovers right at the runway, and a plane is like landing is like, come on guys, like the probability is so out there that we don't probably need enhanced containment. But you know, the Europeans want it, and I seem to, from the previous UK rules when we worked with clients doing BVLOS, they're not waivers. You guys, I forget what the term that you guys use in your old system.
And it's gone from my head as well momentarily.
Alteration approvals or something like that. Yeah, so they would require an independent FTS, and I'm actually really curious to see where your regulator will go. There's merit to both systems, and there's a balance there. Like personally, I would love to see the UK just follow what the Europeans are doing, but that's not possible probably. Funny enough,
that's a whole separate question and a discussion for another time.
I was in the UK the week before and the week after Brexit. So that was an interesting time. Imagine voting matters. But I'll stop being political at this point. So yeah, so basically enhanced containment is something that is required under certain conditions. And I think when we go to like, say, jump 5 years, 10 years from now, I think you'll see most parachute recovery systems have that enhanced containment independent FTS feature. And these are architectural designs, and there's different ways to accomplish it. And I can say this from working with drone manufacturers now, like, you know, just in the last 2 weeks, we've had, you know, 6 drone manufacturer meetings with different people around the world, South America, Europe, and they're all saying, okay, we'll just start designing like this. So to the pilots, I apologize for your pain today for parachutes and flight termination systems. I can tell you that it's not going to get better tomorrow, but in the future it will be. You got to be patient for your diversity of options. Yes, you'll have DJI products right now, and you'll start seeing other manufacturers. And I think that highlights like Skydio, AV, all of these companies are realizing that they have to do it. It would have been nice if they did it 3 years ago. I know I can say that from my business perspective, but people don't like to design things till the customers need it, and the customers don't want to buy it until they absolutely have to need it. And that's on our regulatory. So this is our human reality that we have to deal with.
What methods are used for flight termination? Is the connection to UAS power bespoke between drones?
Yeah, so it depends on the drone. I'll stick with DJI. There's really two ways to make an enhanced containment version. One I don't agree with because it's what we call surgery. You're opening up the drone, you're soldering right into the ESCs, or you're going right into the motors. If you're not the manufacturer and you don't have their approval directly to do that, that's very like a liability wise. I wouldn't take that on. We do that approach for what we call orange wires. So we use that enhanced containment approach to kill motors for our flight testing. So I can stop 1, 2, 3, 4 motors to simulate failures, but we don't offer that product. I don't want drones coming all over the world, coming into here, shipping them out. Yes, I could have a shop in Europe and do this work. We know how to do it. We do it all the time for our own testing, but it's something like you're modifying an aircraft. And if you don't have the manufacturer's approval, like you're just that's just, and like some will say, well, the DJI is okay with it. It's like, okay, do you have a formal document that says that? Because like if that's the case, then I believe you. But until then, I don't believe it. And that comes from like the French market historically, that approach. And then another one that really I think stems from what I saw, the Italian market. So in Italy, the old rules were that you needed a flight termination system for certain missions. So companies started looking at putting in systems that go between the batteries and the drone, the power supply. And that's how we approach it for like the M300, the M200, M30 for enhanced containment is having a separate module that sits between the drone and the battery. And that's kind of the approach, the two approaches. The module is obviously heavier. There's a little more cost to it, but you're not opening up a drone, taking apart like, hey, I take apart DJI drones all the time to fix them because we're not an authorized repair center, but we have to fix our own drones. It's just practical. And so we know it can be done, but it's like, I don't want to be going in and like dealing with the warranty, dealing with the liability, dealing with the insurance risks.
Yeah. Okay. That's really good. Okay. Are there any more questions? I'll give you a couple of moments to add those in. I think we have covered all the questions we talked about yesterday, including the Transport Canada audit with the self-declaration side of things. That sounds a rather interesting side of things, in that the industry somewhat shot itself in the foot.
Yeah, that one was like, we knew it was coming, and we tried to tell dealers like, hey guys, I know someone, like the problem is that I don't know if it's Canadian culture, but it's like, oh, it's on this government website list, it must be good. And it's like, it says just above it self-declaration, which means someone just said it. And there's fines if they make false ones. So they can make false ones. The problem is Transport Canada didn't really look under the hood for 5 years. And I think it boldened some people to like go and make these declarations. And ultimately it's something that you're just screwing your pilots, your customers, and you're hurting your brand. Yes, when you can just put your drone up there or your parachute up there and you can start getting pre-orders, it's great for a business side, but you better have the paperwork. And this is what it showed. We've had a Chinese parachute company get removed. We've had self kind of hobby level parachutes get removed. We had some drones that were removed that were put back on the list because it was more of administrative. They didn't just have their paperwork. They kind of just got maybe too relaxed with the system. But ultimately, I think it's something that the Canadian pilots are going to be more skeptical. They're going to ask for paperwork, and we encourage them, like, ask for the work. And like within Canada for ops over people, ASTM F3322 is a means, not the only means, but it's an accepted means. Whereas the engineering judgment decisions and stuff, we just don't like. Like it's too, like, maybe your engineers made the wrong decisions. Well, industry standards, right? Like industry standards can be expensive, but it's more expensive not to be able to sell your product. And I think it's one of those things where when I'm buying products, if I'm recommend anyone, fine, don't buy ours. There's other industry companies with industry standards that have followed for parachutes. Buy that, but like get the paperwork, get everything, do your homework. And I hate having to say that. Like when I buy a car, I'm not going to Toyota and telling them, give me all your paperwork for your testing. Maybe for Volkswagen, you'll ask for environmental testing, maybe. But it's one of those ones that I understand. Like it's just we're not tuned to do that. But we're in a new industry. Things are growing. There's cowboys still kicking around that are playing fast and loose, and it's I really recommend to pilots to ask for paperwork. And if someone's cagey and says no about paperwork, that means they don't have it, in my opinion.
That would probably be mine too. And I am delighted to hear your professionalism. because that is absolutely something that we advocate both to pilots and to organisations using drones here in the UK. Well, I think we haven't had any more questions in, so I am going to say thank you very much indeed, Josh, for coming along today and talking so informatively about this. As I say, we've been recording this and I will post it up to YouTube and to our website in due course, and I will send out links, links to all those who registered to attend. Quick question, Josh, are you okay for me to add your contact details on there?
Yeah, go ahead. Feel free.
Yep. Excellent. And then if anyone has any further questions, they know exactly how to contact Josh and to continue the conversation. Thank you very much indeed. We've been delighted to have you along here today, everyone, and we will look forward to seeing you again at the next of our webinars. Okay, thank you very much then, everyone. Take care.
Thank you. Bye now.
Bye-bye.